Hello friends, welcome to Nand Kishore classes. Today's lecture is going to be very interesting because today we are going to do a very important question of trigonometry where students usually face difficulties. That is why we have selected this question. A cos theta minus B sin theta. This is given as C and we need to prove A sin theta plus B cos theta is equal to plus minus square root of A square plus B square minus C square. See, this is very tricky question. How we need to start? Please have a look. A cos theta minus B sin theta equal to C. I am going to start by taking whatever is given to us. We are given A cos theta minus B sin theta is equal to C, right? What I am going to do, I am just going to do square on both sides. Squaring here will give me A cos theta minus B sin theta whole square. As of now, I am keeping it as C square only. Okay, and I am considering it as number 1. After that, I am going to continue also. What I am going to do, see, I need to prove A sin theta plus B cos theta is equal to this. So what we will do, I am marking a line here because I have supposed this number 1 because this is going to be used later. As of now, as I told, I'm going to continue. What does that mean? It means I'm going to solve this whole square again. There is no right side. I'm just finding its value. A minus B whole square will be used, which will be equal to A square plus B square minus 2AB, right? Minus 2A cos theta into B sin theta. This is what I am getting. One more step I am going to write. It will become A square cos square theta plus B square sin square theta minus 2AB sin theta cos theta. This is what I am getting after solving it. Anyways, now what I need to prove, A sin theta plus B cos theta, I am going to find square of it as well. A sin theta plus B cos theta. Let us see what value I will get after doing square of it. You must be thinking why I am taking it square. I can see in the right side I need plus minus, right? So plus minus can come when you are having some square. Like x square is equal to 4, it gives you x is equal to plus minus 2, right? That is why I am trying to find its square. Now A plus B whole square formula will be used. What will I get? A square plus B square. Now this time it is plus 2AB. So this is what I am going to get after applying the formula. This is the value, second value, both I have got. I am getting two equations now and I am going to add both of them. What I am going to do, I am going to add this one and this one. Left side will be added to left side, right side will be added to right side. What will happen? See, my left side will become A cos theta minus B sin theta square plus, this is the left side, A sin theta plus B cos theta square. This is what in the left side I am getting. And in the right side, you can see these two terms are cancelled because one is negative and one is positive. So negative and positive are going to be cancelled. And if you check, this is A square cos square theta. This is A square sin square theta. When I am going to add these two, A square can be taken out common. So I am taking A square common from it and writing cos square theta plus sine square theta. And check the next terms. Same way, b square is common from these two terms. While adding them, what I can do, write b square, and in the bracket I'm writing here, I need to write the same thing, sine square theta plus cos square theta. I'll complete the bracket like this. What is the use of this? Use of this is, see, cos square theta plus sine square theta is 1. Sine square theta plus cos square theta is also 1. This is trigonometric identity we can use. If these two values are 1, that means in my right side what I am left with, I am left with only a square plus b square. I am left with only a square plus b square after doing all calculations. So I am recalling it once. Firstly, I found square of this, a cos theta minus b sin theta whole square. Then I found square of a sin theta plus b cos theta whole square. Then I added, left side is added to left side, right side is added to right side. After doing the cancellations, I am getting a square plus b square only. Now check it very carefully. What is the value of a cos theta minus b sin, this value, this equation? I'm highlighting it, please check it. A cos theta minus b sin theta whole square, this is equal to c square. So you can substitute its value here. This is equal to c square, right? If this is c square, what next? A sin theta plus b cos theta whole square, this is equal to a square plus b square. Please check it very carefully. Now what is going to happen next? This plus c square I am removing from here. If plus c square I shift to the right side, what will happen? It will become minus c square, right? And you please check, you are coming very closer to your answer. A square plus b square minus c square. Now next step is taking square root on both sides. If you will do taking square root on both sides, what will happen? You will get this left side a sin theta plus b cos theta. A sin theta plus b cos theta is equal to, when we do taking square root on both sides, you will get answer as, result as plus minus, right? I'm writing in the next line, you will get result as plus minus, and you will have to put square root over whatever the value is there in right side. This is a square plus b square minus c square, and hence this is what I wanted to prove. So this question was a little typical. Usually students cannot, expect that this is the step to be happen. But yes, once they see the solution, next time this concept automatically comes in mind that yes, this is also the possibility. That is why we say more practice in trigonometry is required. I hope you are clear with the concept. Thank you so much for watching today's video.